Hello, this is Bryant, Vanessa, and Stephen bringing problem number 2, which asks, consider the curve given by y squared equals 2 plus xy. And then part A asks us to show that dy over dx equals y over dy minus x. So what we want to do is start with the original equation, y squared equals 2 plus xy. And what we want to do is to prove it, we need to find the derivative. 2y dy over dx equals 0 plus y plus x dy over dx. From here, we're supposed to move dy over dx to one spot, so 2y dy over dx minus x dy over dx equals y. And now that we could take out the dy and leave 2y minus x equals y. What you want to do is divide the entire problem by dy minus x, leaving us with dy dx equaling y over 2y minus x, therefore proving that it does make sense. So for part B, it asks us to find all points, x and y, on the curve where the line tangent to the curve has slope of 1/2. So what we want to start with is the dy over dx equals y over 2y minus x, and from there we're going to solve for x. So what we're going to do is multiply this side by 2, and on the other side by 2y minus x, which is going to get us at 2y minus x equals 2y. From there, all we got to do is solve for x. For x. The two y's are going to cancel out. That's going to leave us with negative x equals 0, meaning x is going to equal 0. Alright, now that we know that x equals 0, we can plug it back into the original equation. Y squared equals 2 plus xy. From there, we're going to plug in the 0 for x. That's going to get us an answer of y squared equals 2. What we're going to do is take the square root. That's going to leave us with y equals positive and minus 2. I'm going to plug that back into the xy coordinates. It's going to get us y square root of 2, 0 square root of 2, and 0 negative square root of 2. Alright, for 2c, it says it asks us to show that there are no points on the curve where the line tangent to the curve is horizontal. So what I wrote here is that the horizontal meaning is representing that the slope equals 0. So what we're going to do is plug 0 into y over ty minus x. And we're trying to figure out what y equals. We multiply 2y minus x on both sides. That'll get us y equals 0. What we're going to do is we're going to put the original y into the original equation, which is going to give us y 0 squared equals 2x 0. And that's going to give us a grand total of 0 equals 2. But we know 0 does not equal 2, so it cannot happen. So there are no points for a horizontal line.
Hey guys, Bryant here. So for part D, we're going to be taking the second derivative. So the first derivative was dy over dx equals y over 2y minus x. To find the second derivative, we're going to use the quotient rule. So y will be our f, and 2y minus x will be our g. So we're going to d2y over d2x equals f prime, which is just going to be dy over dx multiplied by g, which is going to be 2y minus x, minus f, which is going to be y, and then g prime, which is going to be 2 dy over dx minus 1. Okay, so then we're going to distribute. So equals, so dy over dx times 2y would be 2y dy dx minus x dy dx minus, we're going to distribute y to 2y dy dx and 1. So it's going to be 2y dy dx plus y. So 2y dy over dx will cancel out with negative 2y dy over dx. Oh yeah, one minor mistake. Everything should be over g squared. So it will be over 2y minus x squared. Yeah, over here too. 2y minus x squared. And then what we have left over is d2y over d2x equals negative x dy over dx plus y all over 2y minus x squared. And there we have it, the second derivative, right here. Negative x dy over dx plus y over 2y minus x squared. Bye.
Hey, Bryant here, and just making one more finishing touch. Since we know what dy over dx equals right here, we can plug that in, which will get us negative x dy over dx. Whoops, just made the same mistake. You can actually plug in y over 2y minus x, because that's what we proved earlier, plus y over 2y minus x squared. And that is our final answer. You could simplify it further, but for this video, we're just going to leave it like that. Thank you for watching, and this is Brian. Peace.